Okay, so today we are starting with our node voltage method, which is our third method for the theorems, right? Okay. Now, node voltage method is when we have a number of nodes within the circuit. But our main aim is to be able to use the node voltages to determine our current within the system. So here we can say that what we have current I2 produced by the voltage source, and then I1 also from this side, right? When it reaches here, it will pass down for what? I. Just like the branch current method. The only difference is just that we are using nodes, right? So here we have number of nodes. Nodes are where two or more components meet. So we have node here, but then each voltage is there, so we ignore those nodes. And then we have nodes here where a number of what? Voltage source, resistances are all connected. And then we can call this one our reference node. That means that it has what? Zero potential. And then we have what? Our main node here, which is what? We can call it what? Vn or V, right? Now, the next thing we should do is what? To use what? The Kirchhoff current method. In this case, we have what? I1. The current moving towards the junction is equal to the current that is moving away from the junction. So we can say that what? Our I is equal to I1 plus what? I2. And that is our equation what? 1, right? Okay. Then we are also saying that what? After you are done with this, you set up current equation. And then we know that what? Current is always equal to what? The voltage you are resistor. But then when you are considering that, you have to look at what? The potentials. We are saying that current always move from higher potential to lower potential. So assuming we have what? Our current, which is the one moving, right? And then the potential is equal. It means that what? What do you think will happen? The current will not move. But whenever we have a higher potential, that means this side has been raised. You see that the current is moving, right? That is why we are saying that current always moves from what? A very higher potential to what? Lower potential. Meaning that what? Where it is coming from is higher than where it is going. Therefore, you subtract what? Where it is going from where it is coming from in order to get the result, and that will be able to move it. You get it? So here we have our I1. Assigning current for the I1. Current I1 is moving from this direction, right? So it's moving from the zero potential. So this is 0. This one is contributor. In the middle, there's something that is contributing to the source. So from negative to a positive, that will give us what? 20 volts. But then this is where it is going. That means that one is the one, the lower potential. So we subtract it. So that will give us minus what? Vn. All divided by the resistance at that path. And that is what? Our 5 ohms. Now we move on to what? I2, right? This is I2. I2 is coming from this direction. And then we have what? Our zero potential. We have a voltage source from negative to a positive. And the positive is contributing, so 8 volts. And then where it is going is what? Vn. That means that is what? The lower potential. So we subtract your Vn from it. All divided by the voltage source. And that will give us what? Our 2 ohms. And then also we have our I. Let's set up current equation for I. I is moving from Vn to here. That means that where it is coming from is the higher potential. That is Vn. So we can say I will be equal to what? Vn to where it is going, which is the 0 volt, minus 0. But 0 is not needed. All divided by what? The resistance, which is what? 10 ohms. So after you are done with it, you just put it into this current equation and find the value of Vn. After you've gotten the value of Vn, you put Vn here, you get I1. This was I1, right? Then you put Vn here, you get for all the parameters, right? So let's set up the equation. I is what? Vn over what? 10. I1 is what? 20 minus Vn all on what? 5. Plus what? I2, which is what? 8 minus what? Vn on what? 2. So after you are done with this, you can put this equation into your calculator and you get your result. Or you can choose to find the LCM and then you solve it. So me, I want to put everything into my equation. So wherever I see Vn, I put in as what? X. You get it? So we can have what? 20 divided by 10 equal to. So we have alpha equal 20 minus what? X, right? And then divided by 5 plus 8 minus X. All divided by 2. After that, I first shift, calculate, and then equal to. And then your value will come. So we have 20. Oh, sorry. The first one was X. So alpha X. So shift, calculate, equal to. So I had the value of X, which is Vn equal 10 volt, right? So I'm done with this. Then I'm now going to look for the value of I1. I know that I1 was a certain value. I1 was equal to 20 minus what? Vn. Vn was 10. All divided by what? 5. So that will give us 10 minus 10 will give us what? 20 minus 10 will give us 10, right? Divided by 5. That will give us 2. So we have what? Our 2 amps for I1. Then let's move on to I2. I2 is 8 minus what? 10, right? All divided by 2. And that will give us minus 2 on 2. That will give us what? Minus 1 what? Amps. Now let's move on to I. I is equal to Vn on 10.